So hello students, today we are going to start with our next lecture of basics of electrical and electronics engineering, and today in this lecture we are going to cover the star delta conversions. Okay, like here on the board you have seen the two types of circuit arrangements. So this type of arrangement is called as the star connections, and this type of arrangement is called as the delta connections. Like if the resistances are connected at one particular junction, or if the resistances are connected at one particular node, so that one we called as the star connections. And if there are three nodes in the circuits where in between that nodes the resistances are connected, so that we called as the delta connections. And these are the notations that we are going to use in our complete derivation. So if let the terminals are A, B and C for star and delta, then the notations used for the resistances in case of the star connections, so it is RA, RB and RC. That means the resistance that is connected across the node A is RA, and the resistance that is connected across point B, that is RB, and here it is RC. And similarly for the delta connections, the notations that we are going to use are RAB, that is between A and B we are going to use the notation RAB, and between B and C it is RBC, and between C and A it is RC. So these are the notations that we are going to use in our complete derivation. Okay, so starting with the first derivation, that is the conversion of delta into the star. Okay, so in the first conversion of delta into star. So this is our first derivation, that delta is given and we have to convert it into the star connections. Okay, so so this is my delta connection. Okay, this is my delta connection, and here the resistances are RAB, this one is RBC, and this is RCA, and these terminals are A, B and C terminal, and we have to convert this delta into the star. Okay, so let me draw here in the form of dotted, that is my requirement, like this. Okay, and here it is the resistance RA, this is the RB, and here is the resistance RC. That is, we have to get the formula for RA, RB and RC in the form of these delta resistances. Okay, so first of all, starting with the derivation across the terminals AB first. Okay, so first of all, the equivalent resistance across terminals A and B. So these are our terminals. This is terminal A and this is terminal B. And now we have to calculate the equivalent resistance across the terminals A and B. That means RAB, that is the equivalent resistance across A and B for star connection. That means RAB equivalent for star is equal to RAB equivalent for delta. Okay, we have to write down the equivalent resistance for star and for the delta first. Okay, now for star, so these are our star terminals. in between, that is shown in the form of dotted. So these are the star terminals, and if you have to calculate the equivalent resistance across the terminals A and terminal B, so what will be that? Okay, so it comes out to be RA plus RB. So it is RA plus RB. Why not RC? Because here the node C or the terminal C becomes an open circuit. So no current flows through the terminal C. So the equivalent resistance across the terminal A and terminal B for the star connection comes out to be RA plus RB. How it comes out to be? Like this one is, and we have to calculate the equivalent resistance. This is A terminal, this is B terminal, and this one is the C terminal. Okay, here it is RA, here it is RB, and here it is RC. And if you have to find out the equivalent resistance across this point, that means across the terminals A and B, so it comes out to be RA plus RB only, because RC becomes out of the circuit. Okay, so RC comes out to be an open circuit, so no current flows across the RC. So for the star connection, the equivalent resistance comes out to be RA plus RB. That is for the star connection. And now similarly for the delta connection, if we have to find out the equivalent resistance for the delta connection. Now let us see ki, as this is our delta, terminal A, B, C, it is RAB. Okay, and we have to find out the equivalent resistance across the terminal A and terminal B. Okay, यहाँ पे हमें equivalent resistance निकालना है. So what will be that? So that equivalent resistance is when the current flows in this direction and here the current divides. Okay, the same current enters here also. Okay, so that means what is the equivalent resistance for the delta connection? That is parallel combination of RAB with RCA plus RB. ठीक है, ये दोनों आपस में सीरीज हो जाएगा, and this series combination comes to be in parallel with RAB. Okay, so what is equivalent resistance across the terminal A and B? That is the series combination of RCA and RBC in parallel with RAB. So this comes out to be the equivalent resistance. So this is equal to, I am going to write down this for this complete notation. Okay, so here comes out to be RA plus RB is equal to, that is RAB, this one, parallel with the combination of this. Because there is the same current, so that's why these two are in series. So it is RCA plus RBC. Okay, so this is the equivalent resistance for the delta connection. And in the form of formula, so it comes out to be, it can be written as RA plus RB, it is equal to RAB. Here now we have to going to apply the formula for the parallel resistances concept. So it is RAB, RCA plus RBC divided by the sum. It is RAB plus RBC plus RCA. Okay, now this is the complete next equation for this step. Okay, so this one is RAB equivalent for star is equal to RAB equivalent for delta. So from this step we are going to start our derivation, and the next is this one. Okay, and similarly, like here it is RA plus RB. So similarly, if we have to calculate the resistance, equivalent resistance across the terminals B and C. In the first step, we have calculated the equivalent resistance for terminals A and B. And in the next step, we have to write down the same equation for the terminals B and C. So RB plus RC comes out to be. So in the similar way, now we are going to directly write down the formula by following this formula, that is RBC. And here is the left out resistances RAB plus RCA divided by the sum of the three, that is RAB plus RBC plus RCA. Okay, and similarly for the terminals C and terminal A, so RC plus RA is equal to RCA, it is RAB plus RBC. Okay, and divided by the sum, that is RAB plus RBC plus RCA. Okay, so these are the three equivalent resistances across the terminals AB, BC and CA. Now just mark them as the equation number 1, 2 and 3. So let us suppose that this is our equation number 1, this is our equation number 2 and this one is our equation number 3. Okay, now in the next step, subtract 2 from 1. Okay, in the next step, subtract 2 from 1. That is, we have to subtract this equation from this equation and don't mix the left and right hand sides. Okay, so when you are going to subtract this from this, so this RB cancel out and we are left with, on this side it is RA minus RC. Okay, when you have subtracted that, so it comes out to be RA minus RC, and on this side as the denominators are same. Okay, so first of all I'm going to write down the denominator because that is the same, RAB plus RBC plus RCA. Okay, now multiply this with this, minus this with this, and this term cancels out, first term. Okay, so we are left with the first one, that is, one is the RAB into RCA minus this second term and its first term cancel out, and the next term is RBC RC. Okay, so this is the result after subtracting 2 from 1. Okay, now mark this as equation number 4. Mark this as equation number 4. Now in the next step, add 4 and 3. Okay, in the next step, add 4 and 3. Just add up these two equations, and when you add them up, so RC cancel out and we are left on this side with, it is 2RA is equal to, okay, 2RA is equals to, again the denominator is same, so just write down the denominator first, so it comes out to be RAB plus RBC plus RCA. So this is the denominator, and in the numerator it is RAB RCA. So here it is again RAB and RCA. Okay, then one is the minus RBC RCA and here it is RBC RCA. So this cancel out and we are left with only, that is 2 times RAB RCA. Okay, and just cancel out this 2, and now we got our first formula for this required conversion, that what we are doing in the first derivation. So the first formula that we are getting here now, so it is RA is equal to So the first formula is RA is equals to RAB RCA divided by RAB plus RBC plus RCA. Okay, so this is your first formula in the first conversion, that is when the delta is given and you have to got this star connection from this given delta values. So this is the first formula how to calculate this RA. So R is equal to RAB into RCA. This one is RAB, this one is RCA, and divided by the sum of the three resistances. So it is very easy to understood that the resistance that is going to be calculated is equal to the product of the resistances across it in that particular delta connections. Okay, so it is RA is equals to RAB plus R into RCA divided by the sum. And similarly, we are going to write down for RB. So similarly, RB is equals to the product of these two resistances divided by the sum of the three resistances. So it comes out to be RAB into RBC divided by RAB plus RBC plus RCA. Okay, and RC is equal to this one. It is equal to प्रोडक्ट ऑफ दीज टू रेजिस्टेंसेस जो इसके अक्रॉस है डेल्टा में, तो उन्हीं दो रेजिस्टेंसेस का प्रोडक्ट कर देना है. तो आर सी ए कम्स आउट टू बी आर सी इज इक्वल्स टू आर बी सी into RCA divided by the sum, that is RAB plus RBC plus RCA. Okay, so these are the results for your first conversion. Okay, that is to convert delta into the star connections. Okay, so here the delta values are given in the circuit and you have to get the star values from that. Okay, so this one is your first conversion derivation, and from now we are going to convert the star into the delta conversion in the next derivation. Okay, so these are the final results for the delta to star conversion. Okay, these are the symbols used for delta and star. So this one is for delta to star conversion, and in the next derivation we are going to convert the star connections into the delta connections. Okay, so for that mark these equations as number 5, number 6 and number 7. Okay, now the next step is divide 5 by 6. So the first step in this is divide 5 by 6, and when you are going to divide these two equations, so this denominator is same and cancel out each other. So it comes out to be RA by RB is equal to RAB RCA divided by RAB and RBC. Okay, and here again RAB cancel out, and from this equation we have come up with RCA is equal to, so RCA is equal to, it is RBC into RA divided by RB. Okay, so this is RCA comes out to be, and similarly divide the equation number 5 by number 7. So in the next step divide 5 by 7, and in the similar way So here comes out to be RA divided by RC. So denominator cancel out and RCA also cancel out. So we are left with RAB by RBC. Okay, and from here RAB is equal to this one. So this is equal to RBC into RA divided by RC. Okay, this is after dividing the equation number 5 by equation number 7. Okay, now just mark this equation as number 8 and this as number 9. Okay, now in the next step, put 8 and 9 in 5. Yes, in the next step, put 8 and 9 in 5. Okay, this is your equation number 8. This one is equation number 9 and you have to put it into the equation number 5. Okay, so it comes out to be RA is equal to, this is our equation number 5, that is RA is equals to RAB and RCA. So what is RAB? So RAB is this much. तो RAB की जगह पे हम लिख देंगे it is RBC RA divided by RC. This is RAB. Okay, and next is RCA. So RCA is this much. It comes out to be again RBC RA divided by RB and divided by RAB plus RBC plus RCA. Okay, here again put down these relations. So RAB is this much. It is RBC RA divided by RC plus RBC plus RCA is this one. RBC RA divided by RB. Okay, and now just solve it. So it comes out to be RA is equal to, and in the numerator, so it is RBC square. Here it is RBC square, RA square, RA square divided by RB RC. So this is all the complete numerator. Okay, RBC square, RA square, RB RC, and divided by. Now this is the complete denominator, and here again the LCM, take LCM as RB into RC, so it comes out to be, here I'm going to take the LCM as RB RC. So here it is, take RBC common. Okay, because RBC is here also, and here also. So take RBC common, and here comes out to be RARB plus, so this goes out common, and here we are left with RB RC plus RA RC. Okay, in this way, just write down the denominator. Now cancel out this RBC with this square. Okay, and this RBRC, and here it is also RBRC, so just cancel out them also. Okay, so we are left with now, and just cancel out one RA square is here and one here it is RA. Okay, Yes, this is the terminal A. And now the next one is just cancel out that. And now we have to write down this complete relation in the form of RBC. That is RBC equal to what? Okay, so here it comes out to be, after doing all the calculations, so we are left with that RBC comes out to be, when you are doing all that calculations, so we are left with that the RBC comes out to be RARB plus RBRC plus RCRA divided by RA. Okay, so this is your net formula, that is to calculate to calculate RBC from the star resistances. Okay, or you can also write this formula in the form like RB plus RC plus RBRC divided by RA. Okay, so this is your net formula for this conversion. Okay, and similarly, तो RAB can be written as, जैसे RBC लिखा है, तो similarly RAB can be written as RA plus RB plus RARB divided by RC. Okay, and RCA can be written as RC plus RA plus RCRA divided by RB. Okay, so these are your formulas for star to delta conversions. Okay, so these are the formulas for star to delta conversions. Okay, and so this is the complete derivation for star delta conversions. This is a set of formula for converting the star values. As you have seen here, all these resistances RA, RB, RC, these are the notations that we have used for the star connections. Okay, and by applying this formula, we are going to convert this into the delta formulas. So this is your complete derivation for the star delta conversions. First of all, we calculate doing the derivation for delta to star conversion, and then after that, from that we proceed the derivation up to star to delta conversion. So these are the net formulas. Let's write that formula which is available, we got for the delta to star conversion also here. Like this one is for star to delta conversion. Okay, these formulas are for star to delta conversion, and for delta to star conversion, so that comes out to be like RA is equal to, that is RAB RCA divided by the sum of the three resistances RAB plus RBC plus RCA. Okay, and similarly RB is equals to RBC into RAB divided by the sum, that is RAB plus RBC plus RCA, and similarly RC is equals to RCA RBC divided by RAB plus RBC plus RCA. Okay, so this is the another set of formulas. This one is for delta to star conversion, and this one is for star to delta conversion. Okay, and this is your net circuit diagram. Okay, so this is the complete results that we get from this star delta conversion derivation. Okay, so let's try this question. If R, 2R, 3R are connected in delta, find their equivalent star connections. Okay, so like if R, 2R and 3R are connected in delta, now we have to get the star connections for that. Okay, and it is very easy. Like for this star connection, for here, so you have to just multiply these two divided by the sum of the three. Like if we said that this is RA, this is RB, and this is RC, let us name the terminals as A, B, and C. So RA comes out to be RA is equal to this multiplied by this, that is R multiplied by 3R divided by the sum of the three resistances, that is R plus 2R plus 3R. Okay, and this comes out to be here it is 3R square and it is 6R. Okay, so एक R cancel हो जाएगा and it is 1, 2. It comes out to be R by 2. So in this way, you have to apply the formula, and here which formula is we are going to apply? This one. Okay, so these are the formulas for converting the delta into the star. Okay, and similarly, you got RB as R multiplied by 2R divided by 6R. So here you comes out to be with R by 3, and for RC, for this much RC, this is this multiplied by this, that is 6R square divided by 6R. So it comes out to be simply R. Okay, so this is the simple numerical based upon these star delta conversions. So let's try one more numerical with this conversion method. I'm just going to draw the circuit for that on this side. Yes, this one is your question number 1 and question number 2. So your circuit diagram is somewhat like this. Okay, and so this is the circuit diagram. Let us suppose this is P and this one is Q, and here the resistances are, here it is 20, 30, 50. Here it is again 50 and 45. So in this question, you have to calculate the equivalent resistance across P and Q terminals. So you have to calculate R, P, Q equivalent resistance across P and Q terminals. So what are the steps that you have to be followed? Like in this circuit diagram, this 20, 30 and 50. Okay, 20, 30 and 50 are in the delta. Just see this, 20, 50 and 30 are in the delta. So first of all, convert this delta of 20, 30 and 50 ohm into the star connection. And when you are going to convert this into the star, so your circuits appear somewhat like this. So इसको जब star में करोगे ना, तो here comes out to be the star. यहाँ पे और यहाँ पे, ठीक है? तो your circuit will appear like एक इधर और one is here, and the rest of the two resistances keep them as same in the first step. So this your circuit now becomes like this. Okay, this one is the same resistance, that is 50, and here it is 45, but you have to calculate these three resistances first. Okay, now after doing this step, now these two are in series, these two are in series, and net this combination is in the parallel, and that parallel combination is again in series with the upper one. So For this type of question, first of all, convert this delta into the star in the form of this. So here this circuit now looks like this much. Here it is the P terminal and here it is Q terminal. So first of all, calculate this resistance and this resistance. Okay, now after doing for this conversion delta to star, so these two resistances comes out to be in series, this in parallel and again in series. That means once after applying the star delta formulas, then do the rest of the calculation with the series parallel combinations. Okay, and now solve it for the complete answer. Okay, so first of all, we have to apply this delta to star conversion formula, like for this resistance. So this for this resistance, so it comes out to be 20 multiplied by 30. That is the multiplication of this and this divided by the sum of the three. Okay, that is 20 plus 30 plus 50. Okay, and when you solve it, so this will gives you the answer as 6. Okay, and now for this resistance, so this comes out to be 30 multiplied by 50 divided by 20 plus 30 plus 50, and after solving you got the answer as 15. And similarly for this resistance, so it is 20 multiplied by 50 divided by 20 plus 30 plus 50, and after solving you got 10. Okay, so here comes out to be 6, here it is 10, and here it is 15. Okay, and now what next? This 15 and this 45 are in series. This 10 and this 50 are again in series, and this combination is in parallel, and which is further in series with this 6. And after solving all this with the series parallel combination formulas, so you got the final equivalent resistance across the terminals P and Q. So here the final answer comes out to be, so it comes out to be 36. Okay, so the final answer for this, that means RPQ, comes out to be 36. Okay, so this is all for today's lecture, and in today's lecture we have covered derivations related to the star delta conversions. Like firstly we do the derivation for delta to star conversion, and then for star to delta conversion, and then practice some of the numericals related to these conversion methods. And so these are the list of formulas which we got after the derivation. So this is all for today's lecture. Thank you.